Namaste to all. In the last lecture of this chapter, refraction of light, I taught you about the definition, that what are the refraction, what is refraction, what are the causes of the refraction, and also the types of the medium, that is rarer medium and the denser medium, and how light behaves when it travels from one medium to another medium, that is from rarer to denser or denser to rarer medium. Now, a very one important thing, whenever light travels from one medium to another medium, all the properties of the light changes except frequency. Except frequency. The frequency of the light that do not change. Other properties like wavelength and all, they change. Now, today's the very first topic is the laws of refraction. Now, the first law is same as that is laws of reflection, that is incident ray, refracted ray and normal. Please remember, with normal we don't write ray, because normal is an imaginary line at the point of incidence. Incident ray, refracted ray and normal lie at same plane at the point of incidence. At the point of incidence. Now, the second law is the ratio of the angle of sine of incidence to the sine of refraction, always remains constant. For given pair of media. For given pair of media, we can write it in a formula that sine of I upon sine of R is equal to constant. Now, basically the diagram was like this. Suppose this is a glass slab and let this be a point of incidence. This is a normal. So this is the angle of incidence. Now this normal goes like this straight way and it bends towards the normal. So this angle is R. That is angle between the normal and the refracted ray is a angle of refraction. This is the incident ray. So first point, that incident ray, refracted ray. This is incident ray. This is refracted ray and normal. This is normal. All lie at this point. Let this be the point O. At this point, this is the point of incidence at the same plane. Second, the ratio of the sine of angle of incidence, that is this sine of incidence upon sine of angle of R, that is refraction, is equal to constant. Now, given pair of medium is, suppose for all the angles when a ray of light goes from air to this particular glass slab. Fine. If suppose ray of light goes from glass to water, then that will be the another pair of media. Now, this angle sine upon sine of I upon sine of R, as I told you, that is a constant for a given pair of media. Also this constant, that is sine I upon sine R, is known as a refractive index. This is known as a refractive index, but refractive index of second of second medium where the light will enter. Fine. As sine upon as it is ratio, as it is a ratio, so therefore refractive index has no unit. We denote refractive index by n. In few of the book that may be by mu, that is a Greek symbol, otherwise it is represented by n. So we can write it as a n is equal to sine of I upon sine of r. Please remember, this I is angle of incidence, so this it means angle in a first medium, fine, from where the light enter, and this r angle in the second medium where light enters. If suppose the ray of light is coming from glass to air, so that time this sine of I will be the angle sine of I, that is incidence angle in the glass, fine, and this r will be in the angle of refraction in air. The refractive index of a medium gives an indication that how much the ability has medium has to bend the light. More the refractive index, more the bending of a light. The refractive index in terms of the speed of light. Before this, I told you about the refractive index in terms of the ratio of the sine, that is n is equal to sine of I upon sine of r. This is in terms of angles, but that refractive index can also be defined as in terms of the speed of a light, that is Ri, that is refractive index is defined as the speed of light in medium 1 upon speed of light in medium 2. But how we read it as a, that is refractive index of a medium is defined as the speed of a light in medium 2 with respect to medium 1. This refractive index is of medium 2. So we define it as read it as a speed of light in medium 2 with respect to the speed of light in medium 1. If suppose the light is going from air, let the first medium be air and the second medium be glass. Fine. So the way of writing is, it's A, that is air, N, that is refractive index, G for glass is equal to speed of light in air upon speed of light in glass. Now, there is a one thing, that is a refractive index. One is a absolute refractive index, second is a relative refractive index. Relative refractive index. Relative refractive index we define when light goes from air to medium. When light goes from air to medium, or from one medium to simple other medium. But we say absolute refractive index when light goes from vacuum to medium. Now please remember, the more the denser the medium, more the refractive index. The more the refractive index, less the speed of light is in that particular medium. The speed of light in vacuum is, it's 2.9979 into 10 raised power 8 meter per second, whereas the speed of light in air is, it's 2.9970 multiplied by 10 raised power 8 meter per second. Although as both the values are nearby to 3, there is a small difference. Fine. So we take generally we take it as a speed of light in air as a 3 multiplied by 10 raised power 8 meter per second. This is the speed of light in air generally we take. And speed of light in glass is 2 multiplied by 10 raised power 8 meter per second, and the speed of light in water is 2.25 multiplied by 10 raised power 8 meter per second. Now, suppose we have to find the refractive index of the glass. This is with respect to air. Refractive index of glass with respect, basically we can write the refractive index of the glass. So that will be speed of the light, in air upon speed of light in glass. Now let's substitute the value. It's 3 multiplied by 10 to the power 8, and this will be 2 multiplied by 10 to the power 8 meter per second. This is also meter per second. As it is a ratio, so this unit will get cancelled. 10 to the power 8 will get cancelled. This will become 3 by 2, and when you divide, that will be 1.5. That will be 1.5. It means refractive index of the glass is, refractive index of glass is 1.5. Now, another thing which we can judge from this one is in form of sentence, that I'll tell you. But before this, one thing I would like to, you have to only learn the refractive index of that is the speed of light in air, in glass, and in water. Rest for other like diamond and all and spring glass, you do not need not to learn. These generally, although they gives in exam, whenever the question is asked, they give in value in numerical, but still for safer side, better learn those value. Now comes the what do you mean by the term refractive index of glass is 1.5. One more thing that I told just now, that the refractive index of diamond is 2.42. So what do you mean by this statement? Generally question comes like it's given that the refractive index of diamond is 2.42. What do you mean by this term? That I will explain. Now next is the refractive index of glass is equal to 1.5. Now what was the formula? Formula was refractive index is equal to speed of light in air upon speed of light in glass. Now what is the refractive index? That is 1.5. If I will take this upside, so it will become 1.5 multiplied by speed of light in glass, 1.5, that is refractive index. This I will take upside, that will become go in multiply here. 1.5 multiplied by the speed of light in glass is equal to what? Speed of light in air. Now, so from this particular mean is that 1.5 times the speed of light in air. This means that speed of light in air is 1.5 times the speed of light in glass. Just now I told, what do you mean by the term that the refractive index of the glass is 1.5? It means that the speed of light in air is 1.5 times, that is times is multiply the speed of the light in glass. Similarly, if I say that the refractive index of diamond is 2.42, what it mean? It means that speed of light in air is 2.42 times more than the speed of light in diamond. Now, more the refractive index, more the denser, more the bending of the light. Now, the next topic is the refraction of light by spherical lenses. First of all, what are the lenses? A lens is basically a transparent glass bounded by two spherical means part of sphere, spherical surfaces. Now, lenses basically is of the two types. One is a convex lens and second is a concave lens. Now, what is a convex lens? Convex lens, a lens which is thick from between and thin from its periphery ends. Fine. If we keep it lens like this, it will be, the convex lens will be shown like this. Now, whereas concave lens is thin from between and thick from its periphery end. Fine. Now, if we talk about convex lens, the simple convex lens is also known as a magnifying glass. I'll show you. Suppose this is a dot, and I'll show you with the lens. See, I have one convex lens. I'll show you the dot. I hope you can see that it is a quite big in size. Fine. So this is a magnifying lens. Fine. And this lens is thick from between and thin from its both the ends. When we keep lens in a circular form, the lower part, the center part will touch the surface where the rest of the round circular part, the corners, they are lying a little bit above to the surface. Whereas about the concave lens, when we keep the concave lens, then all the complete end that will touch the base, whereas from center it is a little bit upside.